Hello viewers and welcome back to another lecture in this MOOCs on sustainable aviation. So today we are going to talk about something which is very important and is a hot topic nowadays, and that is aircraft energy sources. So many of you might have questioned actually why do we use kerosene? Could not we use something else which is much more cleaner and greener? So let's start with it. There are several criteria in terms of what is required from an energy carrier or an energy source in an aircraft. But two of the most important of them is actually the mass energy density and the volumetric energy density. So the mass energy density indicates as to the amount of energy that can be carried by 1 kilogram of that energy source, and the volumetric energy density indicates the amount of energy that can be carried by 1 liter of that energy source. And both are important because in an aircraft, we require something that occupies very less volume and less mass. Okay, so on this chart, what you can see is that kerosene has reasonably high energy density, both volumetric as well as mass. On the right hand side, what you see is hydrogen, which has high energy density, but volumetric energy density is pretty low. Even if we liquefy it, it is still significantly lower as compared to kerosene. Somewhere in between is LNG, liquefied natural gas, which is basically liquid methane. It has slightly higher energy density as compared to kerosene, but the volumetric energy density is approximately half. On the left corner below, you can see some of the batteries. The volumetric energy density as well as mass energy density of batteries is not good at all. And that's why it is difficult to use them on long range or medium range aircraft that we use in civil aviation. Okay. And just for the sake of fun, I put peanut butter here. You can see that peanut butter, which is a hydrocarbon, has pretty high volumetric energy density and also decent mass energy density. I like my peanut butter, but if you want to reduce your weight, then you might have to think about it. Okay. Now, why do we look at this? Is because of what we call as the snowball effect. You might have already learned about that in the lectures of my colleagues. But what you see is that if you increase the amount of mass of the energy source, then the aircraft weight increases, the lift that needs to be generated increases, the drag increases, the thrust required increases, which means that the engines will require even more fuel. And that means the mass increases again. And this is the snowball effect. And that's why the mass energy density as well as the volumetric energy density is very important. On this chart, you see the amount of power that is required for propulsion from various sources. So when you talk about an e-bike, which is around 250 or 300 watts, to all the way to cars, which have few hundred kilowatts, to buses. But when you talk about aircraft, then it's tens of megawatts to almost 100 megawatts. So when you look at big aircraft like A380 during cruise, then the amount of power that is required is almost 100 megawatt. Now that is very close to a power station, which is few hundred megawatts. So actually, when you look at a big aircraft, then it is a flying power station. Now, this should be kept in mind when we talk about different energy sources naturally. So on this chart, you see some of the popular energy carriers or energy sources like hydrogen, biofuel, synthetic kerosene, then batteries, liquefied natural gas, and liquid hydrogen. And what you see is that and there are several criteria, say for example, energy density, emissions, availability, infrastructure, compatibility, and so on and so forth. And what you see is that none of the energy sources has only advantages. Every energy source has its advantage and disadvantage. And that's why sometimes it is better to combine the two. And that brings me to this slide, which is on hybrid architecture. This is a slide from NASA where they show different architectures possible for hybrid engines, where you combine a liquid energy source like kerosene or biofuel or synthetic kerosene with electric source like, for example, batteries or something else. And just like your car, the architecture can be full electric to turbo electric or something in between like series or parallel and so on. This is a field of research where many people are working, and you will see more developments in this in the coming years. The other way of hybridizing is to combine some of the other fuels. Say, for example, on this slide is an engine that we investigated in one of our projects called as AHEAD a few years back, where we looked at combining hydrogen with biofuel. So the first, what you see here is an engine with two combustion chambers. The first combustion chamber uses hydrogen, and the second combustion chamber uses biofuel. So this is another way of combining different energy sources. This is also an area where a lot of research is happening. So now that we talked about energy source, so let's talk about a couple of myth busting. So the first myth busting is, okay, why can't we fly our aircraft with only solar energy? So what happens if we cover the aircraft with solar cells and that generates enough power to fly? Would that be so? So let's take a hypothetical example where we take an aircraft, say for example, something like a twin aisle aircraft, and we cover it with solar cells, and let's calculate the amount of energy that can be generated. And what you see on this slide is that with some optimistic assumptions, it can generate around 50 kilowatts of power or so. Now that is actually less than the amount of power that is required for the in-flight entertainment system. Even the air conditioning system takes more power than this. Yeah? And please remember that the non-propulsive power requirement in an aircraft is less than 1% as compared to the propulsive power, which is in the order of tens of megawatts. Yeah? So certainly on planet Earth, it will not be possible to fly with solar cells. The other myth busting is the question, why can't we fly with nuclear energy? Well, believe it or not, but it has been tried, both by United States as well as USSR, or now Russia. And the idea was to have these nuclear-powered aircraft, the pictures of which you see on the slide. Yeah. Now, there are several problems when you talk about nuclear propulsion. The main thing is that nuclear reactors are not so light. Moreover, they require a huge amount of shielding because nuclear radiation is very, very dangerous. The other thing is that in an unlikely event of a crash, then nuclear radiation can leak out. And certainly, we would not like to have a nuclear disaster like what has been the case with Fukushima, for example. Yeah. So, but what we can do is that we can indirectly fly an aircraft on nuclear energy. Say, for example, if we use nuclear energy to create hydrogen or synthetic kerosene, and we can use hydrogen and synthetic kerosene created by nuclear energy to fly an aircraft. And that might be something very interesting for the future, an indirect nuclear-powered aviation. Okay. Thanks a lot for watching. See you next time.